Okay, it's recording now. So I'm going to work problem 14.20b. We're given the following dying. Its reaction with HBr at 40 degrees C. Okay. This problem says predict the major product with the addition of one equivalent. So I'm going to make that note here. One equivalent of HBr. Predict the products and then the mechanism. All right, so what's key to this problem is to recognize that this is an unsymmetrical dying. So I'm going to redraw this dying. 3 lines just means equivalent to, with a slightly different conformation. Okay. So looking at my dying now, I want you to see that these are equivalent. 1, 2, 3, 4. Was there a question? Okay. So there's atoms 1, 2, 3, 4 of the dying, and I want you to see those 1, 2, 3, 4 in my new conformation. Now, the key element in predicting the products of dyings reacting with electrophiles is to recognize the symmetry of the dying. So looking between atoms 2 and 3, and I've drawn it in this particular conformation on purpose. This is what we call the S-cis conformation. Okay. That means this single bond, S, is in a cis conformation. This above, the way it's drawn in the textbook, is the S-trans conformation. So when I look at the S-cis and I look at this plane that reflects the two double bonds into each other, what I hope jumps out at you is that these are unsymmetrical. And because they're unsymmetrical, I can have a 1-2 addition here, but I can also have, as I have this numbered, a 4-3, right, which is an equivalent, I'll call it 1 prime, 2 prime, 3 prime, 4 prime, because it's arbitrary which end I number these from. And so now if we look at the products, and we're going to look first at the two different 1-2s, so I could add, and I'll keep the conformation of the molecule the same, so you can see H goes on the terminal carbon, and the Br would go here. So this would be a 1-2 addition product. Then I can add on the other end, so again to number the carbons, so you see these 1, 2. Now there's another 1-2 product where we add, according to the red numbering, 4-3, which again we can call 1 prime, 2 prime. So there's another 1-2 product, and again I will keep the conformation the same. So this double bond will remain intact. There was already one hydrogen there. We're going to add a hydrogen, and then we're going to add Br, and then there was already a methyl group here also. Okay, now this is also a 1-2 product. All right, so that means there are two different 1-2 products. And if we now look at 1-4 addition, That is, if the hydrogen adds 1 and the bromine adds 4, there's the hydrogen that I'm adding. Let me make it red. And there were already 2 hydrogens attached to that carbon. The double bond moves to here. Change colors. There's the Br, and of course there was already a hydrogen attached there also. So this you can see if we number the carbons, 1, 2, 3, 4 is the 1,4 product. But since the two ends are different, we can add the other way around, 1' and 4'. Again, I'll keep this carbon skeleton the same. The double bond will remain there. There was a methyl group and a hydrogen attached to this carbon. And then we'll put the hydrogen on this end. Two hydrogens that were already there on that double bond. Let me put these in explicitly for you here so you see where those are coming from. And then the bromine adds here. So that's a unique compound that we've made. And this is another 1,4 product. All right, so that's the addition. Now let's look at the mechanism. Any questions on that before I go on? Okay, so now still 14.20b, but we're going to look now at the mechanism. So for convenience, I'm going to keep the diene in the S-cis conformation. We have HBr, and what we need to be recognizing are electrophiles and nucleophiles and acids and bases at each step. So if we protonate the double bond, and remember we always start the arrow at the place of high electron density, so I started it in the middle of the bond. I draw an arrow that has 2 heads. That means I'm moving 2 electrons. Recall that if we use the fishhook arrow, this means 1 electron. That means 2 electrons. Okay. We will break the HBr bond. This produces an intermediate. And I'm only going to show the atoms that are critical. We make an allylic carbocation. The other part here is that we still have Br minus. So notice I went from 2 neutral species. I did make a charged species, but my charges still balance. This was net neutral. This is net neutral. Plus and minus cancel. Okay, now key here is our recognition of resonance. So this double bond can move to here, and if that happens, And I'm going to convert that to a CH3 group. Remember, there were 2 more hydrogens here already. This then gives us a different carbocation. Remember, it's a resonance form. It's not really different. The resonance forms are different ways that we represent the molecule. So now, the bromide can attack either end of this allylic carbocation. So if it attacks this carbon and this carbocation, again, nucleophile, electrophile, we get here a net 1,2 product. And I'll redraw the bromide down here. Okay. If that bromide attacks this end of the allylic carbocation, of course that's going to that carbon, it will produce Br, and this is a 1,4 product. All right, so that's the basics. So the mechanism of this is for protonation at this end. Of course, I can protonate at the other end. And this produces a similar but slightly different carbocation. This carbocation has resonance. Resonate that double bond, move 2 electrons. I'll put those 2 hydrogens in explicitly so you don't think they're appearing from nowhere. That's the hydrogen I added. Now don't forget, there was already another hydrogen here. It's still there. Let me not lose that. So again, we had Br minus here. If it attacks this carbocation, I'm still on the page there. I don't really have a view. Let me see if I can get my view. By the way, you guys speak up if I slip off the page or out of the view there. I've got this tiny little thumbnail that I can't really see very well. If we attack this resonance form with this end of the carbocation, we produce a 1,4 product. And if the bromide attacks the other end, we get so this is the bond that I made here, just so that that's clear. When I push the arrow, we get a different product, this one being the 1,2. Okay, and I'll put in explicitly for you that hydrogen that we added right there, so you can see hydrogen and bromine add 1,2.